Welcome back to Chem 330, and we were talking about how to write structures for compounds containing carbon and hydrogens in the alkane family, right? So you can pause the video and write the structures, and if you think you got it right, then you can continue watching the video. If not, go back and watch video 2 and figure out if you missed something that was not allowing you to get the structures right. All right, so here is the number of carbons. I want you to figure out first the number of hydrogens and then figure out how you would write the structures for it, okay? Okay, so the blank is simply for number of hydrogens, and then once you figure out the number of hydrogens, then you can go ahead and write the structure. All right, you can go ahead and pause the video at this time and then work it out and then come back and watch the video. All right, provided you have worked out your math and you have done the structures, you probably should have what I'm seeing now. Okay, let me get my red. All right, so C3, the general formula for compounds containing alkanes is CnH2n plus 2. Going with that sequence, this should have had C3H2 times 3 plus 2 equals C3H8, isn't it? Good. So I should have 8 hydrogens here. Similarly, going with that same analogy here, I should have C5H. Keep putting brackets here. Okay. C5H2 times 5 plus 2, so that would be C5H12. So you should have had 8. You should have had 12 hydrogens. Going with that same sequence, C7H2 times 7 plus 2 equals C7H14. Okay, or 16, sorry. I can't even do my math right. All right, so C7H16, right? So these are our compounds. So let me go get my black color so I can box these. So these are my compounds, right? I guess I can't even do a good job boxing. Okay, these are my compounds, right? So let's write the structures for these compounds. All right, as I said, you first write your carbons in a sequence. As I said, the only element that can connect a carbon to a carbon is oxygen, but we're not there yet. So when I say you alkanes, I'm not referring to any compounds containing oxygen, not at this point. So simply you have to connect the 3 carbons, right, together. Well, there's 2 bonds, because keep in mind each carbon has 1 electron to share with its neighbor, and so you've made 2 bonds between the 3 carbons. Now we also know that each carbon should have 4 bonds because it only has used. Now this is where things get tricky. Well, this carbon is in the middle, so it's already got 2 bonds on either side, so it can only have 2 more bonds, one at the top, one at the bottom. Okay, these are on the outside, so they will always have 3 bonds, right? So now let's get a different color, perhaps a blue, and so each hydrogen can give 1 of its electrons. So I'm going to go first fill the hydrogens and then come back, and you don't need to show the electrons. This is just purely for understanding purposes. You really don't have to show the electrons, but if you start learning it the correct way, guess what? You'll never forget it. You may not forget it even long past the class is over. Okay, and that's not something I have seen. Most students that have taken any chemistry class probably don't remember any chemistry, but it's something you've learned. So how can you forget something you've learned? You probably learned swimming, you don't forget it. You probably learned to play some game, you don't forget it. You probably have learned how to use your phone, you don't forget it. So how can we just forget learning chemistry alone, right? That means we haven't really learned it. Isn't that right? Okay, all right. Okay, that's C3H8, right? C3H8. All right, let's go get, maybe this time we'll start with the black and fill it with blue and fill it with black. So we got 5 carbons, put all 5 in a sequence, okay? Connect the 5 carbons, though, so you'll have 4 bonds between them, right? So this carbon already has one of its bonds, so it will have 3 more, and this already has 2, so it can only have 2 more. This also has 2, so it can only have, so generally carbons in the middle can only have 2, one on top, one on the bottom, and carbons outside will have 3. But that doesn't mean that they only have 2 bonds. They all have 4 bonds. We cannot ever violate the law, which is carbon should have 4 bonds, irrespective of what family it's in. So let's go grab our hydrogens. We start filling wherever there's loose ends with hydrogens, okay? Okay, there we go. That is our C5H12. So C7H16, if you have done your math right, this is probably what you should have had. I'm going to draw my carbons smaller so I have 7 carbons. Hopefully I can squeeze the hydrogens in. So I haven't done anything different than what I've taught you so far, so you should expect what you're going to expect. So hydrogen, 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 hydrogen. Sorry, that little hydrogen is really squeezed in. I don't know if you can see. All right, so we got our C7H16, okay? Now, there is different ways to write it. So what I'm going to show is, what you saw is kind of the open skeleton, because it's like you break open something and you're looking at it, right? So we draw our C3H8, right? So this is how we saw it was drawn, right? Now, the reason I say that is chemistry is not that straightforward that you just learn something and it applies to all cases the same way. It's not like one size fit all. All right, so this is our C3H8, right? There's also another way to write it, which is CH3, because there's 3 hydrogens, and there's a CH. This C is connected to 2 hydrogens, so it's CH2, and then this carbon is connected to 3 hydrogens, so it's CH3. Okay, that is another way of writing the structure. The reason is, if you start writing this even for C7H16, where we would learn a concept called an isomer, it's going to get really tricky. So you may want to first write this for 1 and then quickly switch to, so if I do it for C7H16, so I'm going to write C, actually let me not do it that way, let me erase it. Okay, so I'm going to leave some space, okay, and then come back and connect the bonds. Okay, so I'll first write 7 carbons. Okay, if you remember the structure, actually I'll write the structure first so that you can kind of go with what I was talking earlier. Okay, this is much easier and it takes me less time than using a ChemDraw or other kind of softwares, because they take massive amounts of time. This takes massive amounts of time, but they took even more, so you have to create those structures, and over a period of time, yes, it does get a little bit painful to create, but there's ups and downs to both. So here I have to manually write it, the computer can generate a few. All right, so that is our C7H16, right? So you may want to start practicing this way once you're comfortable with the fundamental structure. This is the fundamental unbranched straight chain structure, okay? Unbranched looks like it's branched, but the carbon itself is all in one straight chain, right? Unbranched straight chain. Keep those words in mind, okay? So we're going to write CH3, CH2, just follow along, CH2, CH2. We are still in 6th carbon, and then you want to write the hydrogen outside. Don't write it as H3C, that is incorrect, okay? Inside and then connected both sides, write it outside, so it's outside, all right? Because as I said, only element that can connect a carbon to a carbon is a oxygen. There's also some compounds that you'll see where nitrogen is doing the job, but it's only one of those two. I don't think anybody else can connect a carbon to a carbon, okay? Let's keep this in mind, because I'm going to stop here, and when I come back I'm going to bring you to an important concept which is just as important, all right?